All right, so we're on to our last section about lines and parallel lines and perpendicular lines. And it's probably seemed pretty basic and you remember doing it all from algebra. So what we're going to do now is complicate everything by turning it all into proofs. So we're going to prove that lines are parallel and prove that lines are perpendicular. And the way that we're going to do that is with theorems. We're going to learn some theorems today, and then we're going to practice using them in proofs. And that's the actual geometry that you're learning. That's the new stuff this unit. So recall from chapter 2 that a converse of a theorem is when you switch the hypothesis and the conclusion. So the converse is not automatically true. If it is true, it must be stated as a postulate or proved as a separate theorem. So that's what we're doing right now is we're going to state all these theorems, and then we're going to state their converses, and you're going to see that they're all true and we can use them in our proofs. All right, so let's move down and take a look at these theorems. Now, when you look at this first one, it says the converse of corresponding angles. Now, you probably remember us reading some sentences and talking about some theorems that started out like this. If two parallel lines are cut by a transversal, then, and we'd say something about the angles. The corresponding angles are congruent. The alternate interior angles are congruent. The alternate exterior angles are congruent. The same side interior angles are supplementary. And the same side exterior angles are supplementary. So you've heard all of these theorems before. We're just reading them backwards now. So today we're going to say if a pair of corresponding angles is congruent, then the two lines are parallel. So we're taking the hypothesis and the conclusion and we're switching them, and that's what a converse is. So when we look over at this picture, if a pair of corresponding angles is congruent, so let's say that angle 1 is congruent to angle 5. Well, then our conclusion is that the two lines are parallel. So our conclusion is that L is parallel to M. So the converse of alternate interior angles. Well, if a pair of alternate interior angles is congruent, then the two lines are parallel. So we need to find our alternate interior angles. So that would be angle 3 and angle 6. So if those were congruent, then L is parallel to M. All right, alternate exterior angles. If a pair of alternate exterior angles is congruent, then the two lines are parallel. So alternate exterior, angle 1 and angle 8, if those are congruent, then you can say that L is parallel to M again. All right, so remember same side angles, they're a little different, right? So if a pair of same side interior angles is, so same side, that would be like angle 3 and angle 5. Well, you know they're not congruent because one's obtuse and one's acute. But if they are supplementary, then the two lines are parallel. So our conclusion would be, if we knew that the measure of angle 3 plus the measure of angle 5 equaled 180, then L is parallel to M. And the same thing for the exterior, same side exterior angles. If a pair of same side exterior angles is supplementary, then the two lines are parallel. So let's say that could be angle 1 and angle 7. So if the measure of angle 1 plus the measure of angle 7 equals 180 degrees, then L is parallel to M. That's our conclusion again. We've got one more that you may not be as familiar with, and that's okay. It says in a plane, if two lines are something to the same line, then they are parallel. So if we look over at this picture, we have two lines, P and Q, and they're both perpendicular to this line R. So in a plane, if two lines are perpendicular to the same line, then they're parallel. So if we look at this picture and it tells us that R is perpendicular to P and R is perpendicular to Q, then we can assume that P is parallel to Q. Okay, so when we're doing proofs, I'm able to write this at the top. These are statements that you're going to make during your proofs, or you're going to see, and these are the reasons. All right, so another postulate that you need to know, and this is just a thing that we don't worry about proving, it's just something that's true, so you need to know it and be aware of it though. It says through a point P not on line L, there is exactly blank parallel to L. So just think about that. Through a point P not on line L. So here's line L. Here's a point P not on line L. There's exactly blank parallel to L. And I'll give you a hint that there's exactly a certain number of lines parallel to L. So if you're going to draw through P and be parallel to L, how many lines do you think you could draw through P that are going to be parallel to L? Okay, the answer is one line. Okay, so through a point P not on line L, there's exactly one line parallel to L. So a couple examples. Given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So angle 1 is congruent to angle 6. So angle 1 is congruent to angle 6. So I see those two angles. They are alternate exterior angles, and they're dealing with line L and line N. So if those two angles are congruent, angle 1 and angle 6, then we must say that L is parallel to N, and our reason is the converse of the alternate exterior angles theorem. And that's on the previous page. We go back. It says if a pair of alternate exterior angles is congruent, then the two lines are parallel. So here's a pair of alternate exterior angles that are congruent, so the two lines are parallel. All right, let's look at example B. So angle 2 is congruent to angle 3. So angle 2 congruent to angle 3. Well, angle 2 and angle 3 are alternate interior angles for line L and line M. So L is parallel to M, and it's because of the converse of the alternate interior angles theorem. And the last one says angle 2 is congruent to angle 1. So angle 2 is congruent to angle 1. Okay, why is angle 2 congruent to angle 1, first of all? Well, angle 1 and angle 2 are vertical angles. They're formed by two intersecting lines. So the only lines involved in making angle 1 and angle 2 are the transversal P and line L. So as far as which lines are parallel, none of the lines are parallel just because angle 1 is congruent to angle 2. Now there may be other stuff that makes them parallel, but just because angle 1 is congruent to angle 2, that just means those two lines crossed. And so while there's no parallel lines, hopefully you still remember our vertical angles theorem. It tells us that angle 2 and angle 1 are congruent to each other. So a couple more examples down at the bottom. Give them a try, and we will check them out in class tomorrow.